In this video, we're going to look at the 27 megahertz system pulsing on and off as a square wave at in the 200 kilohertz range. We're going to run three frequencies. One is 200 kilohertz, and we're going to run that at 50% duty cycle. And then when we do that, we're going to see what the waveform looks like on the oscilloscope. We're going to see if we can achieve quenching. And secondly, we're going to run a frequency of 200 kilohertz, and we're going to reduce the duty cycle to 10%. And we're going to go back to the oscilloscope and see how that looks like in terms of quenching. We're going to see if that quenches. And then lastly, we're going to run 196 kilohertz at 20% duty cycle and see what that waveform looks like. We're also, with each of these waveforms, we're going to test to see what kind of electric field emanates. We predict that if the wave does not quench, that we'll get very low electrical field. But if the wave does go into quenching, the electrical field should spring out and be more powerful. Okay, turn the machine on. First wave is on bank. I have this set for bank 40. Start level 1. Additional bank, no. Beep when done. Yes. Okay, we're running 200 kilohertz. And what we see on the scope is a constant waveform. There's no quenching at this point. If we look at it on the electric field meter, it's a very low electric field. It has no meaning in terms of power. Okay, we're going to now switch to 200 kilohertz at 10% duty cycle. We can see, if I can get it sync triggered here, we can see that it is now quenching at this lower duty cycle. And then if we come back to our E-field meter, the E-field meter is showing a lot more power. I'm holding the E-field meter about 8 inches from the tube, and I'm reading 99 to 100 volts per meter. The system just switched to 196 kilohertz at a 20% duty cycle, and we are seeing quenching happening. There's your quenching, and we're getting a more powerful E-field. Okay, the system just shut off. That's it for this test.